All right, so here we go. The speed of light is 3 times 10 to the 8th meters per second. Convert this into standard notation. Okay, this is where you could pause it and work it through yourself, or just keep going. All right, so this fella right here, this is Mr. Albert Einstein, and he came up with the formula E equals mc squared. And this is all about the Big Bang and how we take energy and matter and convert between them. And that little c right there, that c squared, that's a constant. That's the speed of light squared. So mass times the speed of light squared equals energy. And it explains how we took the energy from the Big Bang and created matter. So the first thing we want to do is work through, methodically. We want to know, what are we asked for? What are we given? We're going to solve and then we're going to check it. So what are we being asked for? We're being asked to convert this number into standard notation. Okay, so we already know that it's going to be, pretty big number, 10 to the 8th, huge. We want to make sure we include our units. So I like to go ahead and write the units down there first, where my answer is going to go. Okay, what are we being asked for? We're being asked to convert a number in scientific notation into standard notation. So what are we given? We're given 3 times 10 to the 8th meters per second. Okay, so basically what I want to do is I'm kind of going backwards here. I'm going to make it a more cumbersome kind of number. So I start with my number 3. And the number 3 would have a decimal place right here. Decimal place is going to indicate when we go below 1, when we go into fractions of a number. And a kind of a cheater way to do this is think that I want to move this decimal place right here. I want to move it 8 spots. And because it's a positive exponent, that means I'm going to move to the right. Okay, positive exponent equals more zeros. And how many are we going to add? We're going to add 8. Okay, we're going to move this decimal place 8 points. So there's 2 ways to do this. I can add 8 zeros. 1, 2, 3, 4, 5, 6, 7, 8. And then my new decimal place is right here. I put in my commas and easy peasy. Or I can manipulate it a little different. I write down my 3. This is where my decimal place would be, and I move it 8 places. 1, 2, 3, 4, 5, 6, 7, 8. Now my new decimal place is going to be right there. And all of these little movements, all of these places that I've moved, I add zeros. 1, 2, 3, 4, 5, 6, 7, and 8. And there's my answer right there. My answer is going to be the number 3 with 1, 2, 3, 4, 5, 6, 7, 8 zeros on it. So 1, 2, 3, 4, 5, 6, 7, 8. And I like to put my decimal place there just to hold it. Put a couple after, and then I put my commas. 1, 2, 3, comma, 1, 2, 3, comma. So there we go. What is the speed of light? The speed of light is 300 million meters per second. Just insane amounts of velocity here. All right. So moving on, the distance from the Earth to the Sun is 1 AU. That stands for an astronomical unit. That astronomical unit is going to be that distance right there from the Earth to the Sun. In science, especially space science or even life science with microbio, we're going to use really big, crazy units, big small numbers. So here we go. The distance from the Earth to the Sun is 1 astronomical unit, or 151 billion meters. Insane. Convert the distance in meters to scientific notation. Okay, so what are we being asked for? We're being asked to convert this number into scientific notation. Okay, so my answer down here, it's certainly going to be in meters. Make sure you put units. And if it's scientific notation, I'm always going to have something times 10 to the power of something else. So I like to go ahead and write those. So what are we given? We're given this crazy big number, 151 billion. So many zeros, 9 zeros. Okay, Now, that's what we're given right there. That's one astronomical unit, the distance in meters from the sun all the way to Earth. So I like to add my decimal place. This number is the exact same. Oh, this number is the exact same as this number. I just like to have the decimal there. Okay, so what are we going to do? We want to have the decimal place right here. We want it between the first two numbers, meaning that in scientific notation, I only want to have one number to the left and then my other numbers to the right of the decimal place. So just one number beyond the decimal place. So all I have to do is think, how many times am I going to move it to the left? My decimal place started here, so all I have to do is count.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11.
And that number right there is very important, okay? That means I moved 11 places, 11 times, or excuse me, 10 to the power of 11, because each time, I move one decimal place, it's like multiplying times 10. So that's a very important number to remember. So let's get it all drawn down here. I went 11 places. My decimal place is now going to be between the 1 and the 5, so 1.5. And if there's any non-zero numbers, you want to include those, unless you're told to round or something like that. So my number is 1.5 times 10 to the power of 11. Don't forget to put your units, we're in meters, excuse me, and that's going to be my answer right there. Okay, so the distance from the Earth to the Sun is 1 astronomical unit, or what? 1.51 times 10 to the 11th meter. And there's my answer. All right, now we're going to work on some really, really small stuff. Okay, recording this, it's February 22nd. And COVID numbers are starting to go down, which is awesome. And hopefully, next year when we watch this video, there will be no more COVID if we're all smart and, keep social distance, wear a mask, wash our hands, stuff like that. So anyway, the size of the COVID-19 virus molecule is 8 times 10 to the negative 8. Okay, so this negative 8 is going to represent a very, very, very small number. Give this in standard notation. Okay, so what are we being asked for? We're being asked to give this number in standard notation. Okay, so scientific into standard. So 8 times 10 to the negative 8th. All right, this is a scientific notation number, but we are going to convert it into standard notation. What I like to do is, keep on changing. I like to just write my number right here and put my decimal place. This number right here, 8.00, is the exact same as this number. But for me, it helps me to organize myself a little better. So I know that I have 8, but I want to incorporate this negative 8 right there. That means I'm going to move the decimal place to the left. I'm going to move it 8 places. So here we go. 1,
2, 3, 4, 5, 6, 7, 8. And then all I have to do is go and put the zeros wherever I moved. And there I have it. My answer is 0.000000. Check 1, 2, 3, 4, 5, 6, 8.
Now, there's a couple ways to do this. Moving the decimal place is one way, or you can just look at this 8 up here, subtract 1, and add that many zeros. So 8 minus 1 equals 7, and if you look down here, I have 7 zeros in front of my unit there. So my answer is 0.000000008. 0.0000008. And don't forget your units, meters. That is going to be tenths, hundredths, thousandths, 10 thousandths, 100 thousandths, millionths, 10 millionths, 800 millionths. So millionths, incredibly small number. All right, and now we have another very, very small unit here. This is, just a regular old animal cell, and this right here will be the nucleus. That's where all the instructions, the DNA, the brain of the cell. Okay, so how big is that? It's going to be very, very, very small. So what am I being asked for? I'm being asked to take this number and convert it into scientific notation. Okay, now I can go ahead and start my scientific notation. Times 10, it's going to be definitely in meters. Okay, but because I'm taking a very, very small number and putting it in scientific notation, I'm going to have a negative exponent. So that's very important to think about. Okay, what are we given? We're given a very small number, 0. How many zeros we got there? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, and then my 6 meters. Now, the ultimate goal here is to have the decimal place right here. I just want one number in front of the decimal place as opposed to 6, So I can move my decimal 1, 2, 3, 4, 5, and 6. Okay, so my exponent is going to be 6. I moved it to the right, so it's going to be a negative. My original number was 6. Then I account for moving those decimal places. 6 times 10 to the negative 6. Okay, so there's a couple ways to do it. You can move the decimal like I did, or you can just count. How many? We got 1, 2, 3, 4, 5, and 6. Okay, so a couple ways to find our answer of 6 times 10 to the negative 6 meters. And there is our answer in scientific notation. All right, a population problem. Okay, last year when I created these problems, there were 7,594,000,000 people on the Earth, and of course this number has changed. Unfortunately, we have a lot of people on the Earth. So what I'm being asked to do is take a number that is in standard notation and convert it into scientific notation. I know that my answer down here is going to be something times 10 to the power of something people. And because it's a very, very large number that we start with, it's definitely going to be a positive exponent. So to solve it, all I have to do is move that decimal place. My original number down here was 7,594,000,000 people. Okay, what I want is, instead of the decimal place being right over here, I want it way over here. So how many places, how many powers of 10 do I have to move that? All we have to do is count. 1, 2, 3, 4, 5, 6, 7, 8, 9. So my answer here is going to have an exponent of 9. My answer right down here is 7.594. Don't forget, you need to add those numbers, those non-zero numbers, times 10 to the 9th people. Incredibly large number. Too many people on the planet. If you look right here, it's projected to get even bigger. Oh my gosh. All right.
So when an image is blasted into your eyeball, it travels through your lens back here on the retina and is blasted through your optic nerve all the way to your brain. And that gives you information. Your brain tells you what that light means. What is that image? So how are we going to use this number in scientific notation? What are we being asked for? We're being asked to convert 0.013, so tenths, hundredths. We are being asked to convert this number into scientific notation. Okay, all we have to do is write what we're given, 0.013 seconds. Okay, but 0.13 seconds, the decimal place is between those two zeros, but that's not what we want. We want it right here between the 1 and the 3. So how many times are we going to have to move it? We're going to have to go 1, 2. Easy peasy. 1.3, we moved it 2 places. 1.3 times 10 to the second power seconds. And because it is a very, very, very small number, we're going to make sure we have that negative. So our number, 1.3 times 10 to the negative 2 squared. All right. That's going to be 13,000. Thousandths. I'm sorry. Said that number wrong. All right, and lastly, the mass of the Earth. Huge, huge number. This number is 6 septillion. Okay, a septillion means we have 24 zeros here. And I'm going to write them all out, but we are definitely going to speed this up. So 6 and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24.
All right, and our decimal place right now is after that 24th zero, but we want it between the 6 and that first zero. So all I'm going to have to do is I'm going to move it. How many places? Well, let's go in reverse.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, and 24.
Okay, hopefully you're starting to catch the pattern. You can find some shortcuts here, but 6 septillion is 6 times 10 to the 24th. And that's in kilograms. That's the mass of the planet. And that, boys and girls, is scientific and standard notation. Hope you learned something.